Welcome back to another BGCSE past paper review. Today we're going to review a combined science paper. And we're reviewing here today a paper 2. This is from the year 2020. And again, please remember, always write your school number, your candidate number, your surname, and initials. Again, read through the instructions carefully before you start the examination. Also, please do not open a booklet until you're told to do so and follow all the directives given by the examiner. Now, usually they provide you with a periodic table, so just in case you may need it, you may refer to the periodic table. And so now let's jump into our first question. For this question, it said the table below shows the comparison between different organisms. So on the right columns, we have the features. And so we have legs, wings, feathers or fur, and scales. And on the left here, we have our name of organisms. So we have our yellowtail butterfly, our snapper, our tree frog, iguana, we have Bahama parrot, we have a dog, we have turtle. All right, so let's go into part A. And for part A1, it reads that the organisms can be broken down into the following classes: amphibian, bird, fish, insect, mammal, and reptile. Now, ask us now to classify these organisms into their classes. And so let's go into it and identify all. And so they already named or classify the yellowtail butterfly, which is an insect. So the fish here will be, the snapper will be a fish. And so the tree frog is an amphibian. And the iguana is a reptile. The Bahama parrot is a bird. And the dog is a mammal. The turtle is a reptile as well. All right, so let's go to our next part of question right now. This part of the question now reads that which two organisms belong to the same class? And if you go back to the chart, you realize that the two organisms that are in the same class here is the iguana, which is reptile, and the turtle is reptile. So let's put those as our answer. So right here is iguana and the turtle. Okay, so iguana and turtle, they belong to the same class. They are both reptiles. All right, so let's go to the next part of the question now. We said, give two reasons for your answer. Your answer should not include any of the features listed in the table. So let's talk about two features of reptiles that are not listed on the chart at all. And please remember that some of these features will also go for other organisms as well. And so to be a reptile, first you have to be cold-blooded. So you're cold-blooded. Okay, so a cold-blooded organism. All right, then another reason here is that you lay eggs. Reptiles lay eggs. Generally, most reptiles lay egg. Another one is that they have a backbone, so they are vertebrates. So let's put this as our next option here. Have backbone. We cannot talk about the scale because the scale is mentioned in the chart. Okay, and they say do not use those. Okay, but reptiles, they do have scales over their bodies. All right, now we said give three differences between a plant and an animal cell. And again, what I like to do is to, when I'm talking about differences or similarities, I like to draw a line down the chart right here, make life easier. And then what I'll do is to put the difference on each side. And so on this side, I could have the plant on this side. On this side, we could have the animal, just to make life way easier for you and the person who is marking the examination. And so the first difference, you could number them as well. So you can say number 1. That's the first difference we'll talk about. And so in plant cells, they have chloroplast. Okay, so plant cell have chloroplast. Okay. And so in animal cells now, there's no chloroplast. Okay, so no chloroplast present. All right, so another difference right here, and they said 3 differences, but we could do more than 3. All right, interest of time, let's go a little bit faster. And so here they have cell wall. So cell wall is present. And on animal cell, no cell wall. Okay. Another difference right here in terms of the plant cell have one large central vacuole. So one large central vacuole, centrally located vacuole. Hopefully this could work. All right, so all right, it's the best vacuole. Okay, all right, it's reached there. And for animal cells, they have more than one vacuole. So we for animal cells, more than one vacuoles. All right, great. And we can also have more differences too, because we can talk about, for example, the shape. All right, we can talk about shapes. But let's talk about the nucleus. Just to add one more there. The nucleus, the nucleus for the plant cell, the nucleus is more to the side. It's more to the side of the cell. Okay. While in animal cells, the nucleuses tend to be central located. So the nucleus is centrally located. All right, so those are 4 differences. Again, we can talk about the shapes and so on. All right, but let's leave that there for now, interest of time as well. So let's just jump on to the next question here, question number 2. All right, so this one say that, let's go back a little bit more. It said that some people suffer from acid indigestion when their stomach produces excess stomach acid, which is hydrochloric acid. It said they take indigestion medication or medicine to relieve the symptom. It said the label on a brand of indigestion medicine say that it contains magnesium carbonate, suggest a possible pH for hydrochloric acid. So hydrochloric acid is roughly about pH 3. Okay. So this is about pH 3 for hydrochloric acid. All right. And now we say that magnesium carbonate is mixed with water. What is the color of this mixture after universal indicator is added? So when universal indicator is added right here is that it will become green, because green will be the neutral color on the indicator, universal indicator paper. If we're moving towards red, yellowish red, then it will be acid, and then so you have red to yellow, which is acidic, and then green will be neutral. Moving from green towards blue to violet will be alkaline. Okay. All right. So again, if you're not sure about the pH for acids, you can always remember that the pH for acid is always less than 7. So I just make a note right here for this part right here, just in case you're not so sure and you want to give a general answer. Then the pH, and pH is written as lowercase p, uppercase h. It is less than, always less than 7. Okay, so less than 7. Okay, hopefully you could see that less than sign. All right. All right, so great. Now jumping on to the next part of the question right here. It said the instructions on the label recommend that 2 tablets should be chewed as needed. All right, you're going to chew this tablet as needed. So explain why the instructions recommend that the tablet be chewed when taken. And this is for one specific reason right here. And generally you want to increase the surface area, right? Because when you chew the tablets, they break up in smaller pieces. So this is to increase the surface area. So you want to increase the surface area of the tablet itself, okay? Increase surface area of the tablets, okay? That's the first thing you want to do. And why you're doing this is to create or to ensure greater collision, to ensure, okay, greater collision so greater collision with the hydrochloric acid, okay, to increase greater collision with the hydrochloric acid. All right, causing effective neutralization. So let's say causing effective neutralization. All right, because the tablets will neutralize the acid. Okay. All right, so great. So once you have more particles, the particles can react faster and better, and then it will neutralize it much easier. So what name is given to the reaction between the excess stomach acid and the magnesium carbonate? And this is a neutralization reaction. So again, we say neutralization. It's a neutralization reaction. All right. So part 3, it said give the name of the metal compound the name of metal compound and the colorless gas formed when this acid in the stomach reacts with magnesium carbonate. And so the metal compound here will be magnesium chloride. Okay, so this will be magnesium chloride. All right. And simply because if you do the chemical equation, you'll realize that magnesium carbonate, it will be a double replacement reaction. So the magnesium will react with the carbonate from the acid, right? And you'll break down into carbon dioxide and water. Okay, so that will be again neutralization reaction by changing around the metal and non-metals. All right, and the gas that will form is carbon dioxide. So carbon dioxide will be formed. Okay, carbon dioxide will be formed. All right, so great. And remember, when acid reacts with carbonate, there are 3 things produced. So I could put it right here. The 3 things are produced when acid reacts with carbonate: water, carbon dioxide, and a salt. Okay, so you have a salt form, water, and carbon dioxide. Those are the products when you have acid react with a base. Okay, just to make a note of that. All right, so great. You can always refer to this again: acid plus carbonate, salt, water, carbon dioxide. All right. Now let's go to part C. And part C said that a purple liquid extracted from the red cabbage can be used as an indicator. It will change color when placed in an acid or base. Now the question to the table below shows the color of purple cabbage indicator at different pH values. And so we're starting from red light pink, pinkish purple, blue, blue green, and greenish yellowish. And notice the pH number is increasing. Okay, so pH starting from 2 going all the way up to 12. All right, and so here now it said what color will be observed when the purple cabbage indicator is added to the following. And so sulfuric acid, again, just to make note of this, as a low pH, acids will be pH below 7, right? But we have 3 numbers here below 7, 2, 4, and 6. But point to note that sulfuric acid is a strong acid, so the number will be lower. So here we can say it will be safely red. Okay. All right, so it'll be red. 4 and 6 are weaker acids. All right. All right, and a solution of table salt. So a solution of table salt, it will be around blue, close to a little bit above neutral. So blue will be our color for table salt. All right, so it's slightly alkalinic. Okay. So it'll be blue. All right. All right. So next question here now. It said, what is the general name given to solutions that will change the purple cabbage indicator greenish yellowish? So let's look at what greenish yellow is in terms of pH number. And greenish yellowish, greenish yellow is 12, which means it is an alkaline. A matter of fact, they are strong alkaline, right? But let's say alkaline. The general name is alkaline. So they are alkali substance or alkaline solutions, okay? All right. So let's say alkaline solutions. All right. All right, so great. Now we can jump on to the next question. And the next question here say that the diagram below shows a straw in a glass of liquid when with an apparent break in the straw. So you notice the straw will look partially broken, okay? And if you notice right here, that's where it looks disjointed because the water is in it. All right, and so let's go to what they're asking now. It's a name and define the term that describe the illusion in the diagram above. And so the name of this is called refraction because it looks bent. So because the light appears to be bent, so this is called refraction. And refraction is bending of light. And so to define it, what refraction is? So refraction is the bending okay, the bending of light, okay, when light passes from one medium to another, from one medium to another. Okay, that's what it is. All right, and a matter of fact, I could put even here to make it more stronger, from one medium to another of optically different density, right? Or I could say here to another with different optical density, with different optical densities, okay? Because it's densities that will make the light bend. If it's the same type of medium, then no bending will take place. But once the optical densities are different, then light will bend. All right, so here now it said explain why light bends as it travels between two transparent substances. And one of the main reasons here, because the speed will change. So let's talk about it here. So one, because a change of speed, and that's why it bends. That's one reason there. Another reason is also because there is a difference in refractive index, okay? Difference in refractive index of the material, okay? So difference in refractive index, a difference in refractive index between the materials. And because of this, the direction will change, okay? So a change in direction will take place, just to make a note of that. A change of direction will take place. And that's actually the bending part of it, right? A change of direction. All right, so that's it for that part there. Let's go to the next part. It's a name an object. Name an object that make use of this effect. And so there are a number of object or equipment that use refraction to make things work properly. And one is a telescope. Okay, so telescope is one. Oh, I'm putting this in the wrong place. Let's go down to the bottom right here. So telescope could be one. Microscope could also be one as well. Okay. All right. So telescope, microscope. Okay. So we can have a microscope. Okay. And what we can also have as well, we could have a binocular. Okay, we could have a binocular as well. So those are pretty much instruments that will use these things. Okay. All right. So those are pretty much instrument or equipment that will definitely use refraction to see object. What they do to object, a matter of fact, they all make object look closer. So let me make a note right here that they make objects appear closer. Okay. All right. Good. Now let's jump to the next part of the question right here now. And this part said that the diagram below shows a ray of light entering a substance 2 from substance 1. All right, so we have substance 2 here, and we have substance 1 down, substance 1 on top, substance 2 at the bottom. Here we have an angle of incident, here we have an angle of refraction. All right, let me stay right there a little bit just and see. All right, matter of fact, let's go down to the question. All right, and see what is happening here, and then we go back to the diagram if we need to go back to it. All right. So the first part of the question here now, it said which of the two media is less dense? And first and foremost, you want to think about something here, right? Once the light is in the less dense object, the angle is greater. The more dense object will have a smaller angle. So the angle of refraction here is smaller than the angle of incident. So we can state that substance 1 will be optically less dense, okay? So this will be substance 1, okay? Substance 1. All right, great. And now the next question asks, how would this difference in density affect the speed of the light traveling from substance 1 to substance 2? And so you should also know that when light moves from an optically less dense medium to a more dense medium, then the speed will get slower. So the speed will slow down. You have a slower speed, or the speed will reduce. The speed will reduce. Okay, so that's exactly what happened to the speed. And so there's a reason behind this as well. So I could give you the reason why this happened. All right, so I'm going to give you the reason behind all of this. All right, so let's put this right here and put this in red to give you the reason behind all of this. And this is because in the optically more dense object, which is substance 2, because of more particles, so the presence of more particles, okay, because that's what density is, especially for the same volume. So the presence of more particles, okay, of more particles will cause more scattering, will cause more scattering, okay, more scattering slash bending, okay, bending of the light. All right. So in other words, what the particles are doing, the particles are bombarding the light, and so the light will travel slower. All right. All right, great. All right, but one point to note though, the energy in the light will be the same, just to make note of that. But the movement of the light will be more it have a more difficult time to pass through the particles because you have more particles there. That's why light will travel faster in vacuum, right? Now, part 3, it said draw on the diagram the path of a ray with a greater angle of incidence. So if you have a great angle of incidence, let's say where I could do this. What I'm going to increase this angle right here, and I will talk about this after I do it. So if I draw a new ray, let's see if I could draw this straight. All right, just follow my path. All right, the idea is that it's increased. All right, so it is greater now, so I'm going to make my new angle right here. So it's a greater angle. What you also to know that if you increase the angle of incidence, you also will increase the angle of refraction. Okay, so it will be somewhere about right here. Not a straight line. All right, so it's not straight. There's bending taking place. All right, you know what? Let me try to erase this piece here that I just do. Okay. All right, I will do it over. I'm going to try to make this as straight as possible. All right, so again, the angle of incidence is greater, all right, than what is there before. It will cause an increase in the angle of refraction as well. So I'm going to come really close to this line, but away from it. All right, great. So the angle of incidence will be greater. It also increases the angle of refraction. All right, so that will be right there. Okay, great. All right, so that will be your answer there. And you can actually label them angle of incidence, angle of refraction. All right, and again, you remember why this is so. I could talk about this a little bit. The reason for this is explaining Snell's law, right? So this is explaining Snell's law. All right, so Snell's law actually explains this. So just in case you may need that for next exam. So Snell's law explains this proportionality. And what Snell's law actually explains is that the speed in one object is over the other speed, which is a ratio between the two velocity. It gives a constant. So what is saying that there are a number of things that give constant when it comes on to refraction. So velocity 1 over velocity 2 gives a constant value. All right, so that's one ratio, or what is explained by Snell's law. Another thing that is explained by Snell's law is that the sine of the incident angle as well. The sine of the incident angle, okay, so let's say sine I over sine R will give a constant value, which is the refractive index, right? So over sine R, that also gives a constant value, which is the ratio of refractive index between the two objects, right? All right, and so that is also important for you to note. So Snell's law explains this. So if you should increase the angle of incidence, you also should increase the angle of refraction to get that same value because it is a constant ratio. Okay. All right. So just point that out. All right. So now let's jump to the next part of the question. And the next part of the question here, which is the last part of the question, is to explain the speed of light before it enters the glass and after it enters the glass and after it comes out of the glass. So what about it when it's entering? What about when it comes out of the glass? Point to note is that they are the same, yeah? So the first thing I'm going to talk about that they are the same. They are the same. And there's a reason why they are the same, right? Because guess what? It is entering and leaving. That means it's the same medium, okay? So just to put a note on this, it is the same. All right, and this is because let's put a notation here. It's the same because, all right, because the medium has the same refractive index. Okay, because of the same refractive index. All right, and bottom line is simply because simply because it is the same medium. Okay, it's the same medium. All right, and speed and light will travel the same way in the same medium. And so I could make a note right here that the optical density are the same, right? The optical densities are the same. All right, so great. Now let's jump into the next part of the question here, or another question. This question is finished. Question number 4. It said diagram below shows a food web on a sandy shore in Andros. Here we have a number of organisms. We have a seagrass, we have a seaweed, we have a sea urchin, we have a parrotfish, grouper, the pufferfish, the turtle, the man, and the shark. Wow, man is being eaten by a shark. Be careful out there, yeah? All right. Now, the question here said name the type of energy entering the food chain. And the energy that is entering the food chain is coming from the sun, so that is solar energy or light energy. Okay, so you can put it as solar energy or light energy. Okay, solar energy or light energy, whichever one works. Now, for part 2, it said, what is the role of the seaweed and seagrass in the food chain? So now, point to note, they are the producers, right? But what are their function in the food chain? They are the one that absorbing the sunlight, right? And they're converting that sunlight into chemical energy, which is ATP. So their function is to convert, light energy or solar energy, light energy, and put energy into chemical energy. Okay, into chemical energy. All right, and this chemical energy is ATP. In the chemical energy, that organisms, because if that's very important for organisms, in the chemical energy that organisms can use, okay, that organism can use. Because remember, the organism can't use the light energy, okay? So they must use the energy that is produced by the producer, and this energy is ATP. Just to make a note of that, the chemical energy is ATP. All right. In fact, it's sugar. Let's put sugar there because we're going to get the sugar and then we make ATP. So the animals or consumer will get the ATP. The chemical energy here is glucose. Okay, that's what we're going to get. And then the glucose will be used by organisms or other organisms to make their ATP. Okay. All right. So the part 3 of this now is to identify an organism that is both secondary and tertiary consumer. And so that means let's start from here. The seaweed and seagrass, they are producer. We don't need to start from there. We could start after that, right? So let's start from the parrotfish. Let's even go to sea urchin. Sea urchin, parrotfish, only 2. Okay, so that's thus secondary consumer right here. So if we go here, we can say we're looking for secondary and primary. If we come from the seagrass, first, this is primary consumer. The parrotfish is the primary consumer. So we have primary consumer right here, and then we have secondary consumer, tertiary consumer. So the shark is a tertiary consumer. If you come right here again, is a primary, secondary, tertiary, and this will be fourth. All right, so we can come here. So from this line, let's draw this line here. This here, the shark is a tertiary. So the primary, secondary, tertiary. If you come on the opposite side of the food chain, you're going to realize now that the shark is also, let me use this color, coming from a seaweed. So that's a primary and this is our secondary here. So it is both tertiary and secondary at the same time. Okay, so let's go down to answer the question now, right? And so it's both secondary and primary, that is and tertiary, that is a shark. All right. And then now it's a part B. It said, from the food web above, construct a food chain containing or consisting 4 different organisms. So again, let's count the amount of organisms that will make up a food chain right here. As a matter of fact, this yellow line is perfect. But we can do a different route. So we can start from here. I'm going to start from here. Mainly because I want grouper into it. I don't know if I'm thinking about grouper, but yep, we could go here, right? Or maybe I don't want to see the man eaten by a shark. All right, so it could be seagrass, parrotfish, grouper, and man. All right, this is a nice, nice food chain right here. All right, we could also go from the seagrass, parrotfish, man, and shark, but again, I really don't want that today. All right, so let's go to this food website. Again, let's remember this. So seagrass, parrotfish, grouper, and man. All right, so let's go put that right here. So our food chain that we're going to draw is going to be here, going to be seagrass. So let's put it all the way out here so it could hold properly. So seagrass, okay, is one. And remember that you must have your arrows. Very important. The arrows show the direction or the flow of energy or what is eating what. And then we'd have our parrotfish. All right, and after parrotfish, again, arrow. And then after that, we'll have our grouper. Grouper really tastes good. Trust me, grouper tastes good, especially fried grouper. Oh my gosh. All right, and then the man. All right, so that is our food chain. All right, so for part C now, it says consumers and producers are included in the food web above. It's a name under the group of organisms which are part of every food web but not shown. Now, the food web here is showing the producers, showing the consumers. You cannot put omnivore because omnivore is they are consumers as well. Just to make a note of that if you're thinking that. So the only thing is not shown in this food web or typical food web here. Matter of fact, let me just go back. I'll show you something, right? Because there's no omnivore shown in this. But you cannot put omnivore because it said another group of organism that is not shown. And it said here is a consumers and producers are included. It's a name another group which are part of every food web but not shown. Omnivore, again, they are consumers, right? Okay. All right, so name another group of organisms which are part of every food web but are not shown. And so we can put here it is a decomposers. Okay, so we can put decomposers here. Okay. All right, so another group which is not consumer or producer is decomposers. Okay, and the function of decomposers explain the importance of this organism, of this group of organism. So decomposers are very important organism, extremely important organism. One, because the purpose of them or the importance of them is to break down. Okay, so they are very important to break down dead organisms. Okay. And the reason why they do that, they break down dead organisms, and this will contribute to recycling of nutrients. Okay, all right, that will assist with the recycling of nutrients. Okay, of nutrients in the environment. Right, they're very important. All right. So part D now is that the population of parrotfish was reduced by overfishing. Now it says suggest how the overfishing of parrotfish affects the population of groupers. And then it say the effects right there and say explanation. So let's go to see what's happening between the parrotfish and the grouper. So again, they take out a lot of parrotfish. So parrotfish is gone. Let's make an X through that. So parrotfish now they are gone. So grouper has nothing to eat. So therefore the grouper population must decrease. Okay, so that's what's going to happen there. So the population, the effect is that the population will decrease. So you have a decrease in population. All right. And the reason for that is simply because the food source or source of energy. Okay, the food source or source of energy supplied to the grouper is being decreased. Supplied to the grouper is being decreased. Okay. All right, so that's exactly what happened there. So less energy, less food, then the grouper will decrease. All right, let's go to the next question here. This is question number 5. It says substances in nature undergo a number of changes. These changes can be placed into two categories: physical changes and chemical changes. A student carries out two experiments to investigate types of changes. And so the first experiment, experiment 1, is that the student uses apparatus set up below. And so here you have gas A, you have gas B, you have a white solid form right here. The gas that's coming from, the gas that is formed is because the cotton ball soaked in ammonium hydroxide, while the cotton on this side is soaked in hydrochloric acid. And so it said name the type of changes that result in the formation of gases from their solution. And this change is a physical change. Okay, so this change is physical. Okay, so physical change. And a white solid formed, a white solid from the two gases. So when the two gases meet, a white solid, that means it'd be a chemical change. Okay, there's a chemical change when the gases meet and they react. It said write the formula for gas A. Gas A, which is here, it is ammonium hydroxide. Let's draw that in. So ammonium hydroxide is NH4. Okay, NH4 and OH, ammonium hydroxide. All right, and for gas B, which is hydrochloric acid, that's going to be HCl. Let's put it out here so don't be confusing with the other part. This is HCl. I actually could type this piece in. Okay, so HCl. All right, that's the formula there for the gas. All right, so now let's go to the next part of the question. All right. The next part of the question is said name the process which caused the formation of the gases from their solution. And once gas is coming from the solution is a liquefied substance, then you're going to call it evaporation. All right, so this process is called evaporation. Is how would a decrease in temperature affect the formation of the gases from their solution? And so if the temperature decreases because you need high temperature or higher temperatures for evaporation, then therefore the formation of gas will also decrease, okay? Or the rate of formation, the rate of gaseous formation or gas formation will decrease. All right, because less gas will be formed, okay? Because a lower temperature means less evaporation, all right? Particles move slower, all right? And so hence less evaporation. Now for experiment 2, it said the student uses iron and records the following observations. So here we have experiments that eats powdered iron, which is a gray solid, and carbon, which is a black solid, and they eat it strongly in the same container and leave it to cool. And as a result of that eating process, over time you have a black solid formed. Now exposes a small piece of iron to moisture and water for 7 days. And what you get here is orange brown solid formed on the iron, which flakes off upon rubbing with sandpaper. And so part D said name the type of change that result in the formation or production of the black solid. So if the black solid is formed, it therefore means a reaction between these two substances, right? So even though carbon is black, you do not see any more gray, and simply because and you apply high heat as well, which is energy, so therefore there's be a chemical reaction. So this is a chemical change here. But the fact that they say something else is formed, it simply means that is a chemical reaction. And in this one now, a new product is also formed. So this here is also a chemical reaction. All right. Now for part E, it says state 2 ways that a physical change differs from a chemical change. All right. And so let's talk about that. Again, I like to put my lines down the middle, but they have lines. You could just write them directly in sentences. But just to make life a little bit easier and things to become a little bit more clearer, I'm going to just put my line there. And on this side, I'm going to talk about my physical change. Okay, this would be my physical on this side. All right. And on this side, I'll put my chemical on this side. And so one major difference here is that this physical change is easily reversible, okay? Easily reversed, okay? So it is reversible reaction, easily reversible. And this one now, it is not easily reversed, okay? Not easily reversed. That means you cannot go back to where you're coming from that easily. But in physical change, you can separate the stuff that you actually mixed together or put together. Or if you move from solid to liquid, you can go back again to that solid. All right. All right. So for part 2 here now, the next thing we could put here that for physical change, you get no new substance. Okay. No new substance is formed. Okay. No new substance is formed. But in a chemical change, a new substance is formed. Okay. You must get a new substance. New substance or substances. All right, is formed. All right, so new substances or new substance or substances, whether the case may be. All right, so that's the end of that question there. Now jumping down to this question, it says distinguish between a conductor and an insulator. Now, this question is kind of a general question because they're not specifying whether or not it is conductor of heat or conductor of electricity, but I'm going to make a general statement as well. So I'm going to say right here now that a conductor now, a conductor allows heat or electricity. I'm going to make it general for both, or electricity or electric current. All right, to pass through. Okay, to pass through it. While an insulator does not allow heat or electricity to pass through it. Okay. All right. So there we have it. All right. So next part of the question is using the list below, classify them as conductors and insulators. All right, so here we have iron nail, we have plastic spoon, we have graphite rod, we have a piece of rubber. So the iron nail is a conductor. It will pass through it easily. And also the other one on this will be the graphite. So the graphite rod is also another conductor. And they can conduct both heat and electricity, by the way, the graphite rod. And for insulator here, we'll have our plastic spoon. Okay, so plastic spoon. And also the piece of rubber as well. Okay, the piece of rubber is also an insulator. Now for part C now, it said the diagram below shows a pot of hot water. It said what are the properties of the pot's material that would allow the following: water to get hot. And the property there is because the metal part is a conductor. So I'm going to say right here is a conductor. Okay, conductor. And we're talking about here is the metal part, just to make a mention of that. So this because of made up of what? Metal. So the pot itself made up of metal. All right. And for the next part here, it says someone to lift the pot with their bare hand. And is because the handle is insulator. So this will be insulator. And this part that I'm talking about here is the handle, just to make mention of that. All right, so great. All right. And so let's jump into the next part of the question here now. It said the electrical wire below is made up of 2 parts. On the diagram, label the part that would be insulator and conductor. So let's talk about the part that is insulator. So this piece here, the wire itself, the metallic part, that's the conductor of electricity. Okay, so that's conductor. The outer part is normally rubber, and so this is an insulator. Okay. All right, so there we have it. Now let's go into the next part of the question right here now, which is question number 7. We're almost there. It said the following table shows the volume of urine excreted by a man after he drinks 1 liter of water. Okay. And so now let's go down to it. We drink 1 liter of water. You have them per 30 minutes each time. And that's the volume of water for each 30 minutes. Go all the way up to 240. It's a use the data from the table to calculate the average volume of urine produced per hour over these 4 hours. So what you need to notice first and foremost is that the time given here is 4 hours. So time is 4 hours. Let's make a note of that. The time equal to 4 hours. All right. Because of the 240, that's 4 hours right there. And then now we need to find the total amount of water. So let's think about the total amount of urine. Total urine. Okay. And let's figure out what the total urine is. Let's go and do some calculation up here. And so if you add 40, 350, 500, 250, 75, plus 80, plus 50, plus 40. That gives us a total of 1,385. Okay. So the total here for the urine will be, come on, it'll be 1,000. Let me take this off a little bit. So 1,385. All right, that's the amount of urine there, and that is in centimeters cube. So we're going to find the average now. So the average here is going to be, let's say average. Okay. So the average now equals to 1,385 divided by 4 because it's 4 hours. And that now equal to 346, 346.25. Okay, and that is centimeters cube. Okay, centimeters cube. Let me just write in my cubic symbol right here. Okay. All right, and there we go. That's the answer there. All right. Now let's jump to the next part of the question right here. We want to move a little bit faster to finish this real quick. Now for part B1 is to explain how the body causes this increase in excretion. So how we have an increase in excretion, right? Explain how the body causes this increase in urine excretion. And so first and foremost, the kidneys will filter the blood off the waste, right? So the kidneys, okay, kidney filters, the kidneys filter the waste from the blood, okay, from the blood to form urine, okay. And so what is also important, from the blood to form urine, and there's something I want to make note of right here. There's some additional information as well. So what you also need to know is that how you excrete more in terms of urine is because ADH, I remember what ADH, we talk about that in about 2 different reviews. It is antidiuretic hormone. So ADH is reduced. So HDA is reduced. That's what is happening. It's reduced, causing more urine, okay, or more water, okay, causing more water to be present in urine, to be present in urine. So less ADH is produced, more water in urine, so you retain less water, okay. And once you have more water in urine, then the bladder becomes fill easier, okay. All right, so more water present in urine, causing the bladder to fill faster, causing the bladder to fill faster, okay. All right, just to make a point there. All right, so great. Now jump on to the next part of the question here. It says state and explain one effect on the body of drinking too much water. And this could be a number of different things that would happen right here. And so one of the things that I want to talk about is that you can have the cells swell or turgid. So one effect here, the cells become swollen. The cells will swell, or we can say it becomes extremely turgid. So they become turgid as well, or extremely turgid. And they may even burst, maybe. Some of the cells may burst, right? All right, and may burst too, right? So if too much water there, the cells can burst. And the reason why they'll burst is because there's no what? Cell wall to hold the cell, right? All right, and they may burst due to lack of cell wall, okay? Only plant cells will have cell walls and prevent their cells from bursting. Besides, let me just put these as well. Beside the cell becomes swollen and so on, what could happen as well as effects in the body is that you can have a water poisoning. Okay, you can have a poison of water. So you have water poisoning taking place too. Okay, all right. Not only that, what you can have is that you have a dilution of minerals. Okay, so you can have a dilution of minerals. Okay, which can be a bad thing because the minerals will not be retained in the body. You would actually urinate them out real quickly. Okay, the dilution of minerals. All right, and you need the minerals in your body. Okay, all right. It's a name the main nitrogenous substance found in urine, and this here is urea. Okay, urea is found in the urine. All right, so let's go to the next question here. So after exercise, after excessive sweating, I should say, on a hot day with a reduced water intake. So exercise more and you have more sweating taking place maybe, or just in the sun maybe. But the fact that you have excessive sweating, right, and you're taking less water, how does the color and amount of urine changes? Now remember, you're losing water by sweating, yeah? And so therefore less water will be in the urine. So the color of the urine will be dark yellow. Okay, that's bad. All right. And then what will happen to the amount of urine? You have less urine. Okay, so the urine will reduce, or you have less. Okay, the reduce or less. It's a give one use of water in the human body, and what is used for a number of different things. And so a number of them, let's name them. It keep the cells healthy. They could keep cells healthy. That's one. Another one could be here is that it uses transport substances, okay, helping transporting of substances, so transportation of substances, all right, very important, all right, because it keeps the blood fluid, so in terms of viscous, low viscosity, and so the blood will flow easily. Also, it maintains temperature, yep, and even sweating is a form of maintaining temperature, right? So maintaining temperature, okay. So that's another function of water in our body, or to regulate body temperature, right? So it's very important for that as well, right? Let's put a star right there. Another thing that water is used for in the body is also to flush out waste. Yep. All right. So the flush out waste flushes waste, or flush out waste from the body, all right, or even from cells. And also it also aids in chemical reactions. All right, I must stop right there because there are a number of reasons. So chemical reactions as well. It aids in chemical reactions, right? So there are so many reasons why we need water. That's why our bodies make up of so much water, because water is very important for almost everything in our body. Now, last question. The diagrams below show 3 states of matter that substance X can exist in. And so we have A, B, and C. If you notice the difference in particles, that's very important right there. So here now it said completely the gaps in the table below by using diagrams A, B, and C. So the state of matter right here, let's keep a little bit of the diagram so we could see it here. So the state of matter in A, they are very far apart, so this will be a gas, okay. The B is very close, so this will be solid. Okay, so this will be a solid right here. Okay. All right, so that will be solid. And C now is not so far apart, closer than A, but further than B. So this one will be the liquid state. And in terms of force, gases have weak intermolecular forces. Solid, they have strong intermolecular forces. Okay, so the forces that hold them together is strong. The movement of particles in gas will be very fast. Okay, so very fast or relatively fast. While the movement of particles within solid, they will just vibrate in their position or fixed position. So they vibrate, all right, vibrate in position. Let me just put position there. Vibrate in their position actually, all right, but in terms of space, vibrate in their position or vibrate in their fixed position. All right, so let's jump on to the next part of question, right? It's a name the process that occurs when the substance changes from C to B, and moving from C to B is moving from liquid to solid. That means freezing is taking place right here. Okay, freezing is taking place. And then now this part asks us now, which is the right. So it's a use the kinetic theory to explain how the change of state identified in B1 occurred. And so we're talking about moving from liquid to solid by freezing. All right. So here now, just to make a note, let's see here. Because this is freezing. Let's go back to make sure that we actually have that. We're moving from C to B. That is freezing. So what happened here when things freeze is simply because there's a drop in what? Temperature. The temperature will decrease, okay? All right, so here now we say when temperature, okay? So when temperature decreases, okay, which means loss of heat, okay? Just to make a note of that. Heat loss, okay? Just say heat loss. All right, so heat loss. The substance lose heat. Okay, so heat loss. All right, so temperature decrease, heat loss take place, and because there's a loss of heat, then the particles now will lose energy. Okay, so the particles they lose energy. Okay, so lose energy and come closer together. Okay, and come closer together. Okay. All right, and come closer together. All right, and so we'll move slower. Okay, and so the particles even move slower. Come closer together and move slower. Okay, and move slower. All right, so that's what happened in freezing process. You lose heat, lose kinetic energy. All right, and so again, decreasing temperature equal to decreasing kinetic energy. Okay, so you can make a note of that, and I should put that in that. So decreasing temperature, loss of heat. And so result in, I could put this piece in here, result in a decrease in kinetic energy, which means less movement, okay? Kinetic energy. Because kinetic energy deals with what? Movement, all right? And so the particles lose energy and becomes closer together, and again are held closer together by that bond, which is stronger than their movement, all right? Again, that's exactly what happened there. And so the last part of the question, it said a liquid was heated and boiled at 100 degrees Celsius with, give the name of this liquid. And we know that pure water boils at 100 degrees Celsius. So this substance has to be what? Water. And we're finished with this lesson. Again, see you next time. Keep safe. Do well on the exam. Keep the faith and keep positive.